to present 3D analysis of small stone implements in the Jomon period. So I will invite Oka to share his screen. Oka, you can just go ahead when you're ready.
Can you hear my voice?
Yes.
Are you okay?
Thank you.
Thank you. And my name is Oka Tomoyasu, MA candidate of Nanzan University in Japan. I always study stone improvements by visual observation, touching, and using a computer. In this presentation, I use 3D models for showing you some production traces and examine the characteristics of the regions which using small stone improvements. I give an overview of this presentation. First, I briefly explain current status and issues of study on traces on stone improvements. And second, I explain the use of SFMMVS and GIS or DM with characteristics of these. And next, I examine a type of small stone improvements by photogrammetry and GIS. Finally, I discuss the production techniques of small stone improvements. These are two purposes in this presentation. The first is to elucidate production techniques of small stone improvements in the Jomon period. And the second is to analyze and show surface traces of artifacts by 3D models. After touching the explanation of stone improvements, I will explain the history of study. Stone improvements are one kind of lithic tools which were basically made by flaking, knocking, and polishing. Stone improvements are thought that were used at rituals. Stone improvements were first created in the early Jomon period, and huge ones were created during the Middle Jomon period. From the Middle Jomon period to the last Jomon period, stone improvements are miniaturized. They are the object which I examine in this presentation. Then, I will explain the history of study on surface traces on stone improvements. Surface traces on stone improvements have been rarely studied other than stone rods. Useful analysis is rarely done, and no result have been obtained. Studies using 3D models have been actively conducted recently, and it is also used for analysis of surface traces. I analyzed the surface traces of stone improvements using 3D models. Considering the lack of surface traces analysis of stone improvements and the fact that surface traces can be easily studied by using 3D models. Then I explain my method. First, I take a picture of stone improvements. I use a turntable and a shooting box for taking a picture. I built a 3D model with metashape based on the pictures and create side and bottom DEM based on the 3D models. Next, I create gradient tint diagrams and contour in QGIS based on DEM. I use a method called SFMMVS to create 3D models using Agisoft Metashape. This is one of the methods to create a 3D model. When you take picture while moving, your computer creates a 3D model by matching the pixels of multiple pictures that show the same things. DEM is a data which have unevenness information. DEM is originally used to analyze geographical features. I use DEM to study small stone improvements by regarding the surface unevenness on them as geographical features. Materials is for object. It's excavated by at Motoyashiki site. Let me explain the result of the analysis. This red circle shows the peaks of the histogram and the corresponding part of these stone improvements. In the histogram, the horizontal axis shows the height, and the vertical axis shows the quantity of coordinates which have the height in the artifact. Side of the first stone improvements flaked from the edge in the centripetal direction. The bottom is national face. Sorry, the bottom is a natural surface. Gradient tint diagram and histogram shows that side are left, but the bottom are flat. Analyzing contour allows you to observe flaking scale in the same way that you create ridges from the contour of a map. The result is this figure. There is no fixed order in flaking, and it can be seen that flaking proceeded to the desired form. Knocking and polishing can be seen in the second stone improvements. No flaking traces are seen. Most of them are only knocking traces. The peaks of the histogram are concentrated on the side, in the center, and on the bottom in the group. It can be seen that the contour is smooth on the bottom, indicating that this is polished. Polishing of the bottom expands to the side, and the side is finely polished to form a curved surface. The third stone improvement is almost entirely polished. A part of the surface is rough because of partly knocking after polishing. The surface is flatter than the second stone improvement. At the bottom, the groove is formed linearly, so there are two peaks in the histogram. It is entirely polished like the third stone improvement. As you can see from the bottom, the left side is thin, so the right side is high. The bottom is the same as the second and third stone improvements. The peak of the histogram is in the groove. Discussion. The first stone improvement is different in size and shape, so it is excluded from the examination of production techniques. Consider the production technique from the characteristics of individual artifacts and the peaks of the histogram. First, the first stone improvement is characterized by flaking in the centripetal direction. Observing the second and third stone improvements, you can see that this was tried to form a ridge at this stage. It can be inferred that the bottom surface is curved upward. Next, the protrusions remaining during flaking are smoothed. This can be seen from the fact that the peaks of the histogram were concentrated in one part in the flaking stage, whereas they were widely distributed in the center of the sides in this stage. In the third stage, the curved surface formed in the second stage is smoothed by polishing. Observing the flaking scar and hammerstone traces, we can see that ordinary hammerstone was used for flaking. Vertical flaking scars can be seen on elongated hammerstones, but not on hammerstones. A vertical flaking scar is formed when it is swung down vertically, and its movement occurs in knocking. In conclusion, the production technique can be summarized in 3 stages. The first stage is forming the outline and ridge of small stone improvements by flaking in the centripetal direction. The second stage is flatten the protrusion by knocking and forming a groove by knocking and polishing. The third stage is smoothing the unevenness by polishing. And I can tell you these 2 things. That is, flaking and knocking traces can be visualized by generating a DEM from 3D models and creating a gradient tint diagram and contour, and analyzing histogram lends to elucidating of processing purpose. Thank you for listening.